Hello and welcome everyone. My name is Kirill Bulat. I'm a computer scientist from Göttingen and part of the EDREP research group. Today my colleague So and I will present our results on applying optical character recognition, also known as OCR, on Coptic. With OCR it is possible to extract text from scanned images. But first, So will tell you something about himself and Coptic.
Hello, my name is Somiyagawa. I am a coptologist originally coming from Japan. Currently, I am a research fellow at the Collaborative Research Center 1136 and the Kelia project, and I am a PhD student at the Seminar for Egyptology and Coptic Studies at the University of Göttingen in Germany. Coptic is a language belonging to the Afro-Asiatic language family. It is the final stage of the Egyptian language, which is mainly used in ancient Egypt. The other stages of the Egyptian language were written in hieroglyphs, hieratic, and demotic scripts. They are combinations of phonograms, logograms, and determinatives. However, Coptic uses alphabets borrowed from Greek and demotic phonograms. Coptic has several dialects, but the most important ones are Sahidic and Bohairic. And in Sahidic, we have tons of important texts, such as the works of Shenute, the Archimandrite, Nag Hammadi codices, and the translations of the biblical books. As I mentioned, the Coptic alphabet is an alphabet which borrowed 24 letters from the Greek alphabet and 6 or more letters from demotic script. It is written from left to right, just as the Greek or Latin alphabet. It has no ligatures in printed text. Several diacritics exist, but they are not many. There are several digital humanities projects in Coptic studies, and many of them need Coptic OCR. For example, Collaborative Research Center, or Sonderforschungsbereich 1136 in Göttingen, creates a text corpus of selected monastic works in Coptic, or digital edition of the Coptic Old Testament in Göttingen creates a digital edition of the Coptic translation of the Old Testament. Also, Coptic Scriptorium of the University of Pacific and Georgetown University, funded by the National Endowment of Humanities, creates a linguistically annotated Coptic corpus. There are a large number of OCR printed texts in Coptic, and these projects need to run OCR on them. We work on making Coptic OCR in the project called Kelia, which is the abbreviation of the Coptische or Coptic Electronic Language and Literature International Alliance. And this Kelia project produces tools like our Coptic OCR application for digital humanities projects on Coptic.
Thank you, So. Let me first introduce you the freely available OCR frameworks that we used for this project. There are two OCR frameworks available, Tesseract and Occupy. Both can be adjusted to work on Coptic. This adjustment is called training. But they differ in this training process. Tesseract, for example, uses font-based training. You need to provide the fonts beforehand, and then those fonts will be recognized. But only a few Coptic fonts are available, and not all historical variations of those fonts can be found. Occupy, on the other hand, uses neural nets and online learning to recognize text. And what it needs the ground truth and the corresponding images. By ground truth we mean that we need a transcribed page and the image of that page. But neural nets get better the more data we have. And in a historical context, we most of the times don't have enough data available, especially if we train on a specific book or a specific language. Then there's also the preprocessing step. Preprocessing is used if we already have a model and we want to remove the noise. That means everything that will mess up our results later on. It can be stains, it can be dust, speckles on the page, and everything else. And so the garbage in, garbage out principle applies. If our images are bad, our output will also be bad. But what if the noise the text itself is the noise or the problem. Let's take at one of our pages. Take a look at one of our pages. What we see here is an almost flawless page, but it still has line numberings that will be prepended and appended on the corresponding line. It still has non-coptic text in them, so models that are not trained specifically for it will not recognize those text. It has additional annotations made by the author of this edition with special characters that might not be available in most of the fonts directly, and those characters has to be added separately again. And this document has also a language variation that's diacritics on some of the letters. You also have to train specifically for diacritics on have them in your model. Or you have two models for diacritics, for text with diacritics or text without diacritics. Luckily for us, Mohib already created Terazact models back in 2013. He trained on all available Coptic fonts, but he only trained on Coptic fonts. That means there is no non-Coptic letter support. He also did not train on for diacritics. And the problem is that non-Coptic letters will get replaced by Coptic letters, and we have to correct the results afterwards. Compared to our discussion before, every red character in this text can be considered as noise and will be problematic on a solely for a solely Coptic model. Our results. We created neural-based Occupy models by training with 10 transcribed pages. And we found out that by training with 10 transcribed pages, we already get better results when with solely Coptic Tesseract models. Even thought that non-Coptic letters there are only a few non-Coptic letters in the pages present. Exactly, we got around 85% accuracy. That means that 85% of all the letters and spaces are accurate. Compared to the Tesseract results, we only got 76% accuracy. This is already quite good, given the fact that we only reduced the line numbers from those pages and nothing more. We wanted also to find out what will happen if die Bilder bewegen sich. We also wanted to find out what will happen if we reduce the noise by removing all non-Coptic letters from the images. And of course, our accuracy spiked to 90% for Occupy and for Tesseract. So the only difference between Occupy and Tesseract at this point is mostly due to diacritics. And in the end, if we remove the diacritics, the Tesseract models get better. But they, as always already said, only give us solely Coptic letter support. Compared to the amount of time we would have used to transcribe all the pages by hand, we found out that it was beneficial to use OCR for this task. Especially since the first 10 pages that we have to transcribe by hand either way can be directly fed into Occupy, and the results can be used afterwards. What we will see is that if you have a smaller amount of if you have smaller book, it's beneficial to use directly Tesseract and correct the pages afterwards. But if you have a bigger book, it's more beneficial to transcribe some pages and feed the results train a model with Occupy. To round up our results is that Tesseract is best for monolingual documents with limited fonts and font variations, since you have to train on every font and you have to include all the fonts and all the variations that you want to have recognized. You can create quite big models, but this is a process where you also get quite a lot of misclassification in the end. Occupy is best for large document sets with multiple languages or stuff that is that even appears quite few times, but deals better with it than training without. What we were able to achieve is that we were approached by Google for collaboration on OCR for Coptic. Google has right now a huge collection of Coptic books that they need to be that they want to be OCR'd. What we also want is to create a Coptic OCR testing dataset where we can test OCR models for Coptic. We want also to transition from typeset to handwritten Coptic text, and the combination of different models was not discussed in this work. Thank you for your attention. If you have any questions, feel free to ask. You can find our models at the link below.